Hi guys, welcome to my channel. Please, if you haven't subscribed, hit the subscribe button. So today we're going to do the nonlinear equations in one unknown, which we're going to do the bisection method and the fixed point method. Bisection method and fixed point method. And fixed point method. Okay, so these are the two methods that we use to approximate the roots or the root of the function. So remember that in the lower grades they taught you that if you have a function f of x which is equal to its nomial x squared plus 2x plus 1, like something like this. They told you that if you want to find the roots, just make this 0. That's why here we say one unknown and f of x is 0. So here we're not going to deal with these. Are easy because you just find you just factorize this, and then after factorizing equate the roots. So this was easy. So now when you go to the nonlinear equations, you're going to find the sum of equations that are not easy to approximate. For example, if you have f of x that's equal to ln of x plus e to the power x, finding the roots of such equation using this method, you can fail, or it's going to be hard for you to find the roots of that. Okay, or sometimes the equation doesn't even consist of a root. So we're going to use a method of approximations to do that. So these two methods, we're going to use two methods, one called the bracketing method and another one called the fixed point method. So the bracketing method is the one that uses bisection. Is the one that uses bisection, and then we are going to have a Newton's method, where this is a kind of a fixed point method. Okay, so we're going to start with we are going to have two methods. As I said, one is going to be bracketing method. So as the name suggests, bracketing, so that means for this one is going to be like we're using intervals. For here we're using intervals. Okay, so and fixed point and fixed point method, you're going to see how to use this and also how to use that. All right, so let's start with the bracketing method, as it's called the interval method. So it's called interval method, also interval method. So method which was going to be, let's name it to, we're going to say bisection method. I'm going to show you how to find the roots using bisection. So in the bisection method, we must have the initial interval. So sometimes if you are not given the initial interval, you must try to find the initial interval by using the initial guessing, or if you are given the initial interval, continue approximating the roots using the initial interval. Suppose that we have a function f. So we assume that function f is continuous on the closed interval a b. So we have something called the intermediate value theorem. So this is going to be useful because if you have a f of x that's continuous on the interval, on the closed interval of a b, and if you have f of a being less than multiplied by f of b being less than 0, this tells you something. So suppose that f of x is something like this. All right, so we are taking the interval from this point. We're taking the interval from this point here, which is going to be a. We're taking the interval from this point, which is a, to this point, which is b. So this tells you that if you see here, so b correspond to the positive. This is f of x. Remember, this is f of x, and then this here is x. So here f of x is going to be a for b. f of x, f of b is going to be positive, and here this is minus, so f of a is going to be minus. So when you multiply these two, you get less than 0. So that tells you that you have a root in between, or a roots in between. So we are going to approximate by reducing the interval by half each and every time. So by using this tells us that there exists c at some point, c as element of open interval a b, such that f of c is 0. So this is if one is positive and another one is negative. There's no way, we must have something. So if here this is a and is negative, and another one here is b is positive, obviously that means the function at some point crossed the x-axis. So if it crossed the x-axis, therefore at that point where it crosses the x-axis, we are going to say that is f of c, where function is 0, because one is negative and another one is positive. Okay, so that's one thing that we are going to use to approximate the root for bisection method. So bisection method says that therefore each and every time, if that's the case, if you have a function f of x, that's continuous on the interval of closed interval a b, therefore exists c such that f of c is 0, and which I showed you using a graph for that one. So always when we're trying to find c, we're going to approximate c. We don't know where c actually is, we just know that's between a and b. So we're just going to reduce the interval by half each and every time. So we reduce the interval by half. Remember that you have a b, so you add and you divide by 2, which is half. Then that tells you that if this is the case, so if we reduce by half, and then we are going to continue finding the f of a multiplied by f of c. Remember that now we got c here, which is a half. So if this is less than 0, tells you that the root lies in between a and c. You see? So if f of a times f of c is negative, is greater than 0, tells you that the root is greater than 0, tells you that the root lie in between c and b. So if it lies between c and b, you are going to take this one here, so this now is going to become a new a and b, and this here is going to become also a new a and b, and you continue finding c. You find c, this is going to be c1, you find c2 up to cn. So this here is going to be, you continue taking this. If the root lies between a and c, and then you are going to say this is a plus c1. And if you are calculating c3 and you find that the root lies between c1 and a again, or c1 and b, you just continue doing the same thing up until. So I'm going to go through actual example and show you how to do that. Okay, so but this is an analogy of how you are going to find the roots. All right, so now